So again, the first thing is separating the x and the y's. So dy is on the left already, so I'm going to move everything y related to the left. So divide the 1 plus y on the left, then therefore I have dy divided 1 plus y. Now I want dx to be on the numerator, so I have to move it to the right side by multiplying it. So copy what's already on the right side, and then multiply the dx onto the right side. So just one step, actually, that's all sorted, separated. Now next is to integrate both sides. Now again, this is a 1 over x scenario, or 1 over something plus the variable, and it's going to give you a similar answer. So this one will therefore be log of 1 plus y, because it's 1 over 1 plus y, equals to log of 5 plus x, and don't forget the constant. Okay, and this is the A part of this question, because we are trying to get a general solution first. At this point, if you want to get rid of your absolute value, and then we need to, as the question says, eliminate all the logarithms. Therefore, we will take an exponential on both sides. So exponential of log 1 plus y equals exponential log 5 plus x plus the c. Again, using our knowledge about the relation between exponential and logs, their opposite calculations, you will have 1 plus y on the left, and on the right side, it's an addition in the index, so we have log 5 plus x times e to the c. And as we can also do, let a equals e to the c as a different constant, then we can rewrite the right side as a, which is the e to the c bit, times the e to the log bit, and because e and log are opposites calculations of each other, so we cancel that effect and just left with 5 plus x. So that's our general solution. That's completely without any logs, and that satisfies what the requirements of the first A part of the question. Now for a particular solution, you just have your expression and you can just plug in the y equals 2 and x equals 1 and obtain the particular solution. So 1 plus y equals 2 equals a 5 plus x is 1. Here x equals 1. And we can solve for what a is. So 3 equals a times 6. Therefore a equals 3 over 6. Yeah, 3 over 6, and that's a half. So our solution then becomes 3 equals a half. No, 3 equals, sorry. We'll have to put that solution back into the general solution so that we don't have a unknown constant. Our constant now is known, that a is known to be a half. Okay, so rewrite that as 1 plus y equals a half times 5 plus x. And if you tidy things up a bit, you should be getting this particular solution that's indicated in the question. So let's times 2 on both sides. So 2 plus 2y equals 5 plus x. And subtract 5 on both sides. I should get minus 3 plus 2y equals x, which is just the equation in the question swapped, left and right swapped. So x equals 2y minus 3. Okay, so that's proved. All right. And sometimes the question will say, calculate the particular solution, which will look like this if it doesn't give it to you, but that's how you would calculate it. Where you question 2, where you are required to find a particular solution. If you're lucky, sometimes after separation of variables, you find that the question is significantly easier given how the variables are arranged. So we'll have a look at question 2 alternative. It looks very much like question 2 that we have just gone through, except the denominator and numerators are swapped around. The mechanism is exactly the same, but this one is easier. So if you can understand the mechanism in this question, then even with a harder question, it's the same process to solve these questions. So again, first thing, we're going to find the general solution by separating the variables. So my dy is on the numerator on the left, so I want to keep it there. And I want my y to go on to the left. So this 1 plus y, if I multiply on both sides, that will go onto the left. And then, because my y is on the left, I want my x to stay on the right side. And I can multiply dx on both sides. That will give me this expression. Now again, just integrate after you've separated the x and the y's into left and right. So integrate 1 plus y. I will get y for the first term. And the second term, raise the power by 1, so y squared, and divide by the number 2. On the right side, 5x plus same thing, raise the x power by 1 to square, and divide by that number. And don't forget your constant. So you can notice that for this expression, that's the end of question A. There's no logs due to the simplicity in the expression after you've separated them. Now, then we'll go to the second step. Simply plug in the condition, and when x equals 0, y equals 2. So we'll just plug in that into the general solution that you just obtained. So plug it in there. So y is 2, therefore it is 2 plus a 2 squared over 2. That should equal to x equals 0, so 5 times 0 plus 0 squared. I'm just writing it down meticulously, but as you can probably see, the whole of the thing involving x will be 0 because x is 0. But let's just be very methodological about it. Plus c. So plugging in the initial condition, I shall have 2 plus 4 over 2 equals 0 plus c. Therefore, my c should equal to 2 plus 2 is 4 That's my C. So after I've got the C, I will put it back in the general solution. So rewrite the general solution as y plus y squared. So basically copying everything down and just changing the C into what C should be, which is 4. And that is your final particular solution.